The data combination test is a versatile technique for the testing of functionality. This technique is also known as the classification tree method. The data combination test can be used for the testing of functionality both at overall system level and at detail level. This technique aims at testing the correct handling of data. It isn't aimed at testing the structure of the functionality. Other techniques can be used to test that. For the data combination test, no specific test basis is required. Any test basis will do, as long as it provides you with the information you need to apply coverage type equivalence classes. Of course, you must be able to make result predictions from the test basis as well. Obviously, the quality of your test cases strongly depends on the quality of the test basis. Like with every test design technique, applying the data combination test consists of 5 generic steps. These steps are 1. Identifying the test situations by applying coverage type equivalence classes and, optionally, additional coverage types such as multiple condition coverage on selected data attributes. 2. Creating logical test cases by combining the test situations into test cases. 3. Making physical test cases for every logical test case. 4. Establishing the starting point. What data need to be present in the database in order to be able to execute the test cases. And finally, step 5. Setting up the test script. In which order will the test cases be executed, which actions and which checks must be performed. These 5 steps will be explained in the next slides by means of a simplified example. The example used concerns a timesheet application. At the end of every month, every employee needs to fill out a timesheet. The timesheet must be approved by the manager. Timesheet codes may already have been allocated by the manager. These are then already visible on the timesheet. When the necessary code is not present, it can be selected from a list. On each activity, it is possible to book overtime. By selecting overtime as yes, an additional line appears. In case of overtime, the employee has to indicate if he or she wants to get these hours paid out or wants to receive them as time for time. If no preference is selected, the manager decides. To finish it later, the employee can save the timesheet without sending it to the manager. Once the employee has finished the sheet, he can submit it to the manager. If the employee filled out less normal hours, these are all hours excluding the overtime hours, than his normative hours, a message appears. Has he booked more normal hours, then also a message appears. In both cases, the sheet cannot be submitted. Step 1 is to identify the test situations. This step consists of 5 sub-steps. First, the data attributes that are of influence on variations in system behavior have to be established. These can be entities, attributes, functional concepts, and so on. The second step is to apply coverage type equivalence classes on these data attributes. This results in the basic set of test situations for the data combination test. Then you identify if there are any so-called strong dependencies between data. This means that a certain data attribute can only be present if another data attribute is in a specific equivalence class. For instance, variations in the data attribute driver's license can only be present and therefore be tested if another data attribute, age, is in the equivalence class over 17. The results of the first 3 steps are then drawn up in a classification tree, which is a graphical representation of the data and their equivalence classes as branches in the tree. Dependencies are being reflected by hanging the data it concerns under a specific equivalence class of another data attribute. The last step in identifying the test situations is an optional one. Depending on the required thoroughness of the test, one or more pairs of data can be defined to be fully combined. This means that every equivalence class of an attribute has to be combined with every equivalence class of another attribute. In the next 3 slides, these steps are applied to the timesheet example. Here we see the data attributes that are of influence on the system behavior of the timesheet application. Timesheet code, overtime, payment of overtime, handling of the timesheet, and the total number of normal hours. We also see the equivalence classes of these data. There's one strong dependency, payment of overtime can only be tested if overtime is yes. The classification tree has been drawn up. The data attributes are being represented by rectangles grouped under the overall concept of timesheet, and the equivalence classes are the branches in the tree. Every branch in the tree is a test situation. Additional test situations have been identified as well. In the strategy, it has been agreed upon that two data pairs have to be fully combined. Every possible combination of total hours and handling must be tested, as well as every possible combination of timesheet code and overtime. Step 2 is to create logical test cases. The logical test cases have to cover all of the identified test situations. On the next slide, we will use the classification tree to draw them up. The branches in the classification tree are extended. Some horizontal lines are drawn. Each of these lines will represent a logical test case. First, you start with covering the defined combinations of data. Test situation set number 2. The first pair to cover is handling and total hours. We draw all combinations of these two data. Another pair that has to be covered is timesheet code and overtime. We draw all combinations of these two data as well, by adding them to the horizontal lines. Set 2 of the test situations, the combinations, is now fully covered. Two things remain. First, we have to ensure that every branch of the tree is covered, the equivalence classes of set number 1 of the test situations. Notice that the branch no preference has not yet been covered. And second, we have to make every test case complete, which means that we have to make sure that for every test case all data attributes are filled. The next slide shows how these two remaining things are added to the classification tree. All test situations are now covered and every test case is complete on a logical level. The remaining steps are creating the physical test cases, establishing the starting point, and setting up the test script. As these steps are basically identical for most test design techniques, these steps are not elaborated here. Depending on the required thoroughness of the test, the coverage of the data combination test can be extended by using additional coverage types, such as boundary value analysis, multiple condition coverage, and/or pairwise testing. These coverage types can be applied to all data or to a specific selection of data.